video, we move to the second part of this chapter 5, talking about the probability. I will have a few videos to discuss these interesting concepts. So within this first video, we will show you is the basic concepts or definitions for probability as our mathematical area. And we will talk about the relationship of O and the relationship of AND with a few of samples. So let's first look at our mind map. I have updated mind map to here. So if you go to the probability, so first, before there is a fourth subchapter referred in the book, I put these some probability definitions here. So those are the key concept. One is what's the experiment, what's the sample space, what's the events, and then the distribution. We starting to talk about the uniform distribution, and in the last subchapter, when we talk about the non-uniform, the random number generation, we will discuss about the non-uniform distribution. So let's look at the book. So what's the experiment is the test that we want to perform. So we perform tests because we are interested in the probability of each possible outcome. So possible outcome means we will expect that getting some result from our the performed experiment. Like rolling a dice, we will expect is a die will have our number either is 1 within the until 6. So it should not be any the other number more than 6 or less than 1, and also they are the integer 1, 2, 3, 4, 5, 6. So you do the rolling dice. That is one experiment from the activity, and what you are getting the result is the that is the outcome of this experiment. And then this sample space is the all possible outcome. So for the rolling dice, is all the possible outcome is from integer 1 to 6. So you don't get any other outcome possible coming from rolling a dice. So that we are defining these whole sets as our sample space. Is we can use our set the method to, or the data structure to define this sample space. And the event is a set of the outcome that we want to calculate the probability, and that form a subset of the sample space. So if we rolling dice 100 times, you get maybe so you have 50 times with 4, 20 times with 3, and then vice the extra. So you get maybe not the full sample space. All possible you get all the sample space, but is even if you got all sample space, that's still the subset to itself. So you get our outcome set that we call the events. Then we have our the definition for the distribution. So we're starting from this simple one, the uniform distribution, which means is each outcome in the sample space is equally likely to occur. Like the dice again is the equally possibility you get 1 compared to the possibility you get 3 or you get 5 or 4. So because we assume this dice is our the fire, or the good quality dice, that they don't have the the equally those weight in somewhere inside the dice. If you are not make that uniform in the weight, then you get some numbers possibility maybe more than others. So, but we assume that is the equally, then you get a uniform distribution from number 1 to number 6. So that also the base why some games we use dice to decide some of the consequences for different teams, and then to represent the uniform distribution, we use this formula. So P is the possibility of the events, and NE is the cardinality of the sets, E the events, and NS is the cardinality of the sample space. So we have this E and S, and then we can calculate this PE. So P is the possibility. So then you can consider is our event is the subset of the sample space. So the maximum event set is the equal to the S. So if that happened, your PE is result is 1. And most of the time is less than S because there's some the element may not be happened or occurs, but it must occur at least 1. So if you don't do any experiment, then you will get 0. But that it's a seldom thing, but we can see that is the lowest boundary. So you can put is the PE is ranging from 0 to 1. That is the reason we have that understanding. And then this we can apply formula to this. Let's do here. So let's list down is we should have from senpai. So import the finite set. So we have this one. So then we can define this S. So let's use the capital S. It's the finite set 1, 2, 3, 4, 5, 6. Then actually we create our set that can represent the dash. So and we put this our E is the events. If E is also another finite set, it's just 3. Then we can see is the NS. Let's see the NS equal to 6. What's that equal? So actually is we remember is we have this length. Cardinality is using the length of sets. So NS is the length S. So let's say NS is 6. Same as NE is the length E. So here. So NE is 1. Then what's our PE? PE is the NS divided by this, it's NE divided by NS. So it's this one. Then PE, you can see, is this 1/6, so 0.166, or normally we see is 0.167. And we can convert this to our the program function probability with 2 argument transfer. One is the event, one is the space, and we return the length of events divided by length of space. Then using that is we can calculate the uniform distribution. So that is our the approach. So in this function, 2 arguments we transferred, and using this function, let's write a program to find the possibility of a prime number appearing when 20 size dice. We assume we have a dice with 20 size rolling. Then we calculate this the possibility or percentage of this the decided divided number result for the prime number appears. So let's create our code. So 0, 5, 0, 2, 1. So prime in 20 side dice dot, or we see just die.py. So let's make our purpose. Find possibility, or we use this formal name is probability of our prime number appearing in our 20 side die is rolled. Okay, we have our header. Then let's see. So we should have some library. So we will use the set. So we should have the from the SymPy import finite set. If you read the book, you can see here the author didn't show. Doesn't show this import, so that is please ensure you have this one because you are using this later on. So first let's put our probability the function here. So that is receive. One is our the sample space, another is the event as the arguments. Then simply just return the length of event divided by length of space. So now we have our function. Whenever we want to calculate the uniform this distribution result, we just call this probability the function. And also we need to restore is or resume our memories on the one is how we can check the this prime number if you are giving a number. So let's make this check prime apply to our argument of a number. So then is let's see. So from the Python is we also can check is if the number. So let's see. Like users author, we gave this full name. If a number is 1, then we will return false. So the prime number is not starting from 2. So then is we will ask the people is to input something is more than equal or more than 2. So if it's not 1, then we will do something, and else we just return false, and others we will return true. So then is let's add the logic for this checking. So checking is with remember, yeah, if you look at my other videos, I have another video talking about the basic C program. There's a kind of the detailed discussion to see how to implement prime number check in language C. So, but we have certain the authoring the discussion. So definitely the principle for check a prime number is from 1 to the numbers. If there's no any the number between can be the factor of this the original input number, then this will be the prime number. So that is the direct thing is for factor. We will see the factor in range 2 to, but we let's see, so do we need to go to the number? That is too wasting of the computer programming. So let's just say it's int. We should go to the half number. That is already enough. Because if we go to more than half, then that's it's just the less than it must be our floating number, so there's no the factors directly. So if we come to here, then that already good enough. Then we save sometimes. So if a number find is those modulo is 0, then return false. So that means is if we find there are any factor, then we return false. Then if we finish this run, then it's nothing. The found, then I will return true. So let's just checking first with this simple prime number check function is working. So let's see. So what is the number is, let's make that integer. So input, please give our positive integer. And I will call this check in print. Oh, so here let's quit. We run. So let's see. So I know 7 is the prime number, and let's see 25 is not. Let's see 29 is the prime number. So you can see at least for now is our prime numbers are correct. So let's make this check test check prime. So let's making them commentate. So let's starting to do our code is we define space is using this finite set. So using this finite set with our the range, you need to have these asterisk. So range 1, 2, we got is 21. So let's also make this to be a variable. So first is the dice face. Let's see. So let's go to our input. Please input the faces of dice. Then I will make this integer, and I make that dice face plus 1. So the plus 1 is means we will ensure is this like 20 face dice sided by the dice will also range to the 20. This is the index, the consideration. Then primes, we put that as the empty, so we will need to check is what are the prime number inside this range. So within that is we will for number in S. So this S actually is the space. So we should check for that. So let's see. So this S actually is space. So I think it's that's another the authors need to check on his the code. So prime. Let's use our prime function, and then we check is if is true, then I will make our primes this list append, which means is I will have these prime numbers. Then let's just press. Let's see. So the event is equal to find, and using also this star with primes. Before we starting to call our possibility, let's do this print. Let's see the our space the sample space zero format. So I also suggest you like these ways. Don't try to finish all the functions at one time. So whenever you finish a tiny additional function, try to think about how you can evaluate that result in print. So because I don't use this probability yet, but here I'm checking is what are the prime number inside my range. So that already good enough is I can try to print these events as our sets first. Then I can validate is whether the prime number find is okay, but how they form our new set is okay. So that is these two I can start. So now let's input 20. So 20 side. So I get this 20 side is from 1 to 20. And here is 2, 3 until 19. So that is perfect. We have our correct sample space set and event sets. Then that's what is the the safe is now we can call P is the probability of space and events. So that again is here. You please notice this S will be the space you need to ensure you are doing. Then let's print the final probability of rolling a prime let's see rolling a prime in let's see this 0-sided dice case. Then that is 1 because we have our phase number as the variable. So we give 5 digits for this prime numbers possibility. Then format first is the dice phase and then P. So we have a little more compared to the samples. So let's save and do. So input 20 first. So you can see probability of rolling a prime in 20 side dice is 0.45. So here I think it's those from 2 to 9 that is a 9 number inside the 20 number. So that is the 0.45. I think it's the authors this decide is it's why I put is 4 as the prime. So that is our the interesting thing. So I go to 4. So let's double check is our the code is we have the range is to here number. So let me see here. So if I don't have this convert to integer, I have this this integer divide. So let's see. So 4 is still here. So that is our the interesting thing. So if I put the number 4 here, so 4 is not 1, so it's coming to here. Factor in range 2 to 2, and there's so that is my I think is the issue because I'm starting from 2, right? So if I make it starting from 1, let's make that again. So 20. That also not good is we only go to 2 and 3. So that let me see here. So it's 1 and 2. So I should think about this boundary number 2 because if I put 4, the divided by 2 is get 2, so it's no, there is a looping, so it's not yet get that, then there's directly go to the true. So let's make that plus 1, so let's 20. So here I have another number, I think it's this missed, so I think it should be add 1. I miss number 2. Yeah, so now is good, is 8. So think about just the double check is here. So for Python is I think I should use this the integer division, then this plus 1 to ensure is we don't miss this boundary 2 when we divide it by 2. Because if I don't have plus 1, then that's a number 4 will be counted as our prime number. That is our lowest boundary, the wrong the values. So now we have this, and also our program is available for you. Is if now you have 100-sided dice, it's very easy. So you get that, and you count the events with those prime number from 1 to 100. Then you can see this possibility is getting lower. So let's making that is the, let's see. So I want to have the 10,000. It will be take time, but it's also not a problem for computer. So I got is 0.122. So actually, is when you have that, is you can start to find our relationship of this dice side number with those possibility. Then it will be easier for you to have that two sets and plotting that into our this visualization. So that is the ways I think is we can also think is how you can visualize your result. So if I don't print this, so let's try this before moving to further. So if I make this 2, so in dice, n-sided dice, let's try to see is I want to do, I don't want to print that. So that is give then P. So if we don't do this plotting, so do these inputs. So let's make it our dice. Phase equal to range. Let's say 1 to 100. Then we get this one, and we can calculate this. So maybe it's 4 dice phase in range. Then we make all of them. And let's see here. So we have our dice phase, and we put is the probability. P is equal to just the prob is our empty. Then I will have this and prob dot append P. So now I have another list for every dice, and let's see. So plot what's this dice phase prob. Let's load this plot. Import plot. Oh, it's we need to wait is I put this too many the calculations. So I have adjusted a little bit. So possible is we can use just the plot. Let's see here. So within the SymPy, we have our plot function. So if I don't have this, it should be easier for, let's put in here. Let's run this. It's getting some errors. A non-type object is not iterate. So let's not go to this one. So I load the matplot this lib. So let's delete this, and just for showing here, let's ensure is we have that. So I load this PLT as we learned before, and create these two the empty site empty list size as the x, probability as the y, and we put this size is just append for this dice space one by one to ensure is when we append one x, we append one y. So then this we can say plt dot y label is the probability of prime number, and the plt x label is the die size. Then let's make that 1000 to have a look. So leave that calculating. You can also check, I will rename this to _2. So then you can check for this. We just use this SymPy equation. So let's try to see. Oh, that's good. If I make that bigger, you can see from 0 equal is suddenly is they starting from the more than the 0.65 or maybe 6.7. So then this come to the what we calculate is 0.4. So that possible is the let's make zoom here. So you can see 20. 20 is almost 0.4. So let's make this. Then you can see gradually is decrease. But it's kind of stable when we have a huge numbers size. Then it's approaching to 0.2. So this way is you can see we have the x and y labeled, no problem. So you get our idea is when you do something with our statistic way, then it's better you think about how to visualize that. And then let's make a simpler part testing on this probability of two events. When we say O means the event is either in A or in B. When we say and is the event is both in A and B. So that is the in very simple the set theory is we have this two symbol to define that, and what we have put in is in this O relation is we will use union. So first we calculate the O result is you have two sets and you calculate union sets, and then you put this union result size as these events, the sets on the this length E. Similarly, is if you want to calculate the and, first you will do this intersect, and then you get this E and you use the length E divided by length this space, the possibility space. So that is the simple one. I don't show that manually. You can read this small chapter. And in the next video is we will discuss is how to generate a random number on this the part is we generate a random number in this uniform the distribution manner. Then is we talk about in the uniform the distribution manner. So let's see in the next video. So see you then.